Assalamualaikum. My name is Afma Parvin. I'm from Group J to present our exploration into the realm of AI algorithms, where we have delved into the world of mobile price classification. Our primary focus has been on implementing Python code for supervised machine learning algorithm, utilizing the power of AI to analyze and interpret datasets, providing valuable insights through classification. We choose to the mobile price classification dataset from Kaggle, a treasure trove of sales data from various mobile companies. Imagine Bob, an entrepreneur eager to complete the giants like Apple and Samsung. He faces the challenge of estimating the price of his mobiles accurately, and that's where AI comes to the rescue. A supervised learning scenario where we aim to predict the price range of mobile phones based on their features such as the RAM, internal memory, and more. It's not just about predicting the price, it's about understanding the intricate relationships between these features and the selling price, enabling Bob's company to make informed decisions in fiercely competitive market. As we embarked on this journey, Python became our trusted companion, providing a versatile and accessible platform for implementing AI algorithms. Though multicast coding and thoughtful analysis, we aim to showcase the effectiveness of supervised machine learning in solving real-world problems. In our presentation, we will walk you through the steps from dataset selection to algorithm implementation. Witness how we unravel the hidden patterns in the data, providing Bob with the tools to make informed decisions about these mobile prices.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fanzaki. I will continue about the algorithm here. So we start uh, by choosing the what we call data set at the Kaggle. So we choose mobile price data set. So after that we load the data set from the CSV file and perform the essential data pre-processing steps. Sorry, to ensuring the dataset mm, consistent. We change it to the numeric here. So using this scikit-learn, we split the data into training and testing here. So it's a crucial step in evaluation of our data. So the sorry, our data performance. Okay, sorry. After that, now let's dive into the core of our algorithm. We iteratively train the KNN model with different value of k here. So to understand it, the impact on predictive accuracy, we observe that the model perform vary with the choice of k. So we can see here, we use the k equal to 5. So in the code we got the k equal to 6, 7 and 8 and more. And then sorry, we visualize our model performance by using the confusion metric here. Okay, so offering a detailed look into the ability to correctly classify instance in each price range lah. So the metric allow us to calculate precision metric for individual classes, providing valuable insight into the model's strengths and weakness. Okay, you can see here that we have the confusion metric graph here. So here is a performance metric calculation. The explanation will be explained by my friend on the code part. Okay, in conclusion, our study shed light on the predictive capability of KNN algorithm by meticulously exploring different key value and evaluating model performance. We uncovered insight into the algorithm behavior on our datasets. So our finding emphasized the importance of hyperparameter tuning in achieving optimal model performance. We identify a specific k value to maximize accuracy and precision. This result provide, I think, a solid foundation for further refinement and exploration for the machine learning. I think that's all from me. We will go to the next part. This is the what we call the code explanation by Brother Haras. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haras and now I will explain about how we implement KNN, K nearest neighbor, into our dataset, which is what we found here is mobile price prediction. So first we will import the necessary libraries. We will and now we take the dataset and put it into pandas data frame. So you can see this is the first 5 rows in the data frame, but it starts from 0. We don't want that, so we just drop the 0, and then now it starts from 1. After that, we check the info, and as you can see, this info is the data type is like float 64 and int. So we change the data type into numeric, and now after that its data type is object, so we can calculate the um, this one to KNN. So we can see the unique value of the target class, which is starts from 0. 0 is the lowest and the highest is number 3. So if it goes like 0 1 2 3. And now for the X, we will take from battery into Wi-Fi, and for the Y, we will take the price range. So here we can see drop the price range and take all of it, and here we can see that we take the price range, and then we split the data set and train them, which is 80/20. And now this is the shape of the training and testing. So now we set the value k, which is 5, and then we make the prediction of our model. We first of all we train them, we feed them, and then we make a prediction. And this is the prediction. And after that we calculate the accuracy score. So you can see the accuracy of this model is 93.5. This is the highest right now, K5. And then we check K6. Is it higher or lower? So after that, you can see the accuracy model is a bit lower than K5. So we check the K7. K7 is 94.25, which is higher than K6 and K5, which is 94. And then we make K8 to see if it more higher than that, but it's lower. And we make K9. uh, K9 is 94.25, same as K7 94.25. And then K10 92.5, it goes lower. K11 K12 goes lower than that, so we take K9 or K7 because both of them are the same, 94.25, 94.25. So we made the confusion matrix for this, and we can see there is 92 at the first row. 92 is correct and 1 is false. So we plot the confusion matrix into this uh, graph plot, which is more bigger and more clearer. We can see 92 1, this one 109 for 4, 84 is a true positive, 6 and 3 is the false positive, and so on. Class 0, class 1, class 2, class 3. So we calculate the true positive of every class, and this is the true positive. And then false positive, which is this is the calculation for the false positive and false negative. So after that, we calculate the precision, which is true positive divided by true positive plus false positive. We calculate for all of this class, class 0 until class 3, we sum it, and then we got our precision model, which is 0.94 or 94%. For me, this model performs very well. I mean better, which is because it is 94%. It performs good because the precision is at least like 90% and above. So I think that's all from me.